Hi. In the next few minutes, we're going to take a look at how AWS Silicon Innovation is changing networking both in the cloud and across the enterprise. With me here is Brad Casemore, Research Vice President for Cloud and Data Center Networking at IDC. Hi, Brad.
Hey, Peter, it's great to be with you today.
Brad, I know you've written about how customers are accelerating their transition to the cloud. Um, how do you think Silicon Innovation is changing the demands on the network infrastructure over that process?
I think it plays a very significant role, Peter. It plays an integral role. And I think if you look at it, there is a flywheel effect that really comes into play because cloud infrastructure was designed, of course, to accommodate applications and workloads, to support them and deliver them.
Mhm.
And as applications have moved to the cloud, it's driven more innovation in terms of the underlying silicon, the hardware systems on which the silicon is based, and of course, the software and services that support workloads in the cloud. And that process continues. It continues with newer applications such as Kubernetes applications, cloud
Mhm.
native apps. And it's continuing now as we move into AI workloads. And I think obviously the silicon innovation is the foundation for the hardware advances that enable applications to perform faster, better, with greater availability, greater reliability, greater scalability. And
Mhm.
really, it's a foundation for all of that.
So it feels like the combination of migration to the cloud and increased usage of purpose-built silicon has meant that more people are thinking about the network more than ever. Is that what you're seeing?
Absolutely. They're thinking about how the network supports and enables those workloads in the cloud. If you think about it, what do you require as you move forward? You're using applications that are ephemeral. You're using applications that have extremely high throughput requirements, extremely high latency requirements in terms of low
Mhm.
latencies, consistently low latencies at that. You're looking
Mhm.
at losslessness. You're also looking at things like power consumption, which is very important to organizations as they look at achieving their green IT objectives.
Mhm.
And network silicon is a huge contributor to that. It's again, I think essential to making it happen. So, as organizations think about certain workloads that are very
Mhm.
demanding in terms of their losslessness, the losslessness requirements, the low latency requirements,
Mhm.
the throughput, the elastic scalability. I think, obviously silicon is the foundational aspect to enabling all of that.
We're saying much the same thing. Customers tell us that their applications um, they need to be able to offload processing for the network so that's not being done on the main processor. Um, obviously, very fast, high bandwidth instances, like we've got the P5 instance up to 3.2 terabits per second. But there's also things like congestion control on the network and low latency, but also consistently low latency.
One of the interesting things, Peter, about what you just said is the smart NICs play an absolutely critical role in offloading, for instance, network and security services,
Hmm.
allowing the CPU and, of course, the workloads that run on the CPU to get the full amount of resources they require for
Hmm.
business purposes. And I think that's critical from an enterprise perspective. They obviously want their business applications to run at peak performance to deliver digital experiences to their customers, partners, and others.
Hmm.
And one of the ways you do that is through that smart NIC that you talked about. It offloads a lot of functions that are critical but ancillary to the business workloads.
Hmm.
What you also said was very interesting about we'll call it the traffic management across the network, the queuing.
Hmm.
If you think about all the flows that are running on a network, you have what we call elephant and mice flows, the very large flows that can be time consuming and can get in the way. They're small in number, but they're very
Hmm.
important, but can get in the way of the many, very high number, the proliferating number of mice flows. And with smart queuing, you can obviate that problem and allow obviously the network and the servers that are connected on the network, on the data center network, to get all the resources they need to satisfy the business applications.
So as these applications move to the cloud, how is that changing how organizations are thinking about other parts of their network?
Yeah, Peter, what we're finding is that really this is having an effect across the network. Obviously, the data center network in the cloud has to provide all those performance attributes that you and I have discussed. But the implications for the network extend beyond what's happening in the cloud data center. It actually reaches across the WAN to, of course, enterprise on-premises environments. And I'll give you an example of what we're seeing. We have predicted in IDC's Futurescape, our worldwide cloud 2023 predictions, that by 2025, which isn't that far away, about 70% of enterprises will adopt cloud WANs and transit networks to improve availability, latency, performance, reliability, and scale of their cloud workload applications. And I think that's a very critical insight that you just raised. And our data really bears that out, that the implications of wanting low latency, of wanting the lowest possible losslessness, of ensuring that you get end-to-end bandwidth and throughput extends beyond the data center and out across the WAN. And cloud networks, when you think about it, are purpose-built for that, not only in availability zones and regions, but of course, these are worldwide networks, right, with extremely capable backbones. And depending on customers' needs, it could be within a region, across a continent, or even worldwide, these networks are extremely well suited to the workloads that are in the cloud. And similarly, we see that, again, this is where the 2 points of the compass collide. In the data center too, we see, and this was the following prediction in that report, by 2027, 80% of our organizations will invest in specialized cloud-based performance-intensive computing environments to gain agility, scale, and faster business insights. And of course, faster business insights are absolutely critical to serving customers and providing better digital experiences, and for organizations to achieve competitive differentiation in the marketplace. So again, that's where they meet, right? In the data center, there's all this innovation that is attracting workloads because you're able to provide specialized hardware based on silicon innovations. And then across the WAN, you're able to provide the performance attributes that customers need to ensure that low latency, availability, throughput, scalable bandwidth is really available right across the full path.
What are you hearing from your customers? Where are they investing in the future?
Yeah, absolutely. What we are finding, and we have more data for that, is that we're seeing that certain criteria are being used to evaluate where applications should run. And in a survey that we did for our Future of Digital Infrastructure, we asked enterprise respondents, what are the criteria that are most important when it comes to determining where to run your workloads, whether that be on-premises data centers, edge, or public cloud infrastructure? And what we found is most of the criteria cited, most of the attributes that these respondents felt were critical, actually were characteristic of cloud infrastructure. Things like security, where of course tremendous investments have been made from the silicon up to provide very high levels of security within cloud data centers. Things like access to advanced public cloud services and emerging technologies. That's really in the wheelhouse of everything we've been discussing now, Peter. And there are a number of other attributes there, such as business continuity and recovery, looking for the ability to have failover environments that will ensure application continuity, performance guarantees, speed of deployment, of course, the agility of cloud, and a number of other key attributes.
It sounds like customers are looking at moving to a very cloud-centric model for their enterprise networks. What is their timescale for doing that?
Yeah, it's definitely accelerating. And I'll give you a great example. If you look at what's been happening with Kubernetes, if you look at what's been happening generally with the migration of new and pre-existing workloads to cloud, organizations say, well, I really like the agility, I really like the flexibility, I really like the elastic scalability, the security, the consistent low latencies, the performance that I'm getting from my cloud environments. I really want to implement a cloud operating model everywhere, right? So across the WAN, wherever the edge, within their own environments, they're adopting cloud practices and operating models right across the network landscape. And it's changing what's required from network operations. There's a lot more focus today on agility through automation, for instance. There's a lot more focus on orchestration. There's a lot more focus on day two, having insights that provide better remediation of any sort of troubleshooting that needs to occur. And all of this is being done now really pursuant to a cloud operating model. So cloud has influenced not just architectures, it's influenced infrastructure, and now it's having a very pervasive effect on network operations as well.
That's very interesting. Well, Brad, it is always a pleasure. We really appreciate you taking time to spend a few minutes with us today.
Thanks very much, Peter. It's been my pleasure.